Good morning. Welcome to AP Computer Science A, and A is for awesome. So today we are going to be covering section 1.4. So just make sure that you guys have your notes ready and opened up as we are going over, and you also want to make sure that you have gone into the 1.4 Replit classroom. Make sure that you type in your name. This is period 3. And let's get ready to code. So now, one of the things that in this lesson, we are going to be talking about assignments and number calculations. So we are going to be declaring an integer. And we're going to say integer is going to be, we need to be able to have a variable name. So in this case, to be able to simplify, we're going to place x equals to 9. Now, one of the things that you want to make sure that you are careful when you are programming in Java is that this doesn't say x is equal to 9. 9 is being placed into the variable x. So you want to make sure that you kind of read it backwards. Well, we're so used to saying x is equal to 9. In Java and in programming is different. In this case, you are placing the 9 inside the variable x. So you are working towards that way. So it's something to be able to keep in mind as you are working with assigning a value to a variable. Now, let's say we have, so let's talk about some of the operations that we can do in Java. So we know that we can add by doing a plus in between. We can subtract, we can multiply, we can divide, and then on section 1.5, we're going to be talking about the modulus, the remainder. It's not a percentage sign any longer in Java. That'll be the remainder, but we'll cover that in section 1.5. So for now, let's talk about integer division. When we are dividing, so let's say we have a integer x, or let's say y, because we need to be able to have a different name, right? If we have an x, we're going to overwrite what we had before. Y equal to 2. Now, what happens if I divide? So let's go and say int z is equal to x divided by y, which in this case will be 9 divided by 2. And let's go ahead and print out the value of z. So let's go to system.out.println, and let's do z. And what do you think that will be? So give it a guess. What's 9 divided by 2? Most of us will say 9 divided by 2 is 4 and 1/2, which will be 4.5, correct? But let's go and run it and see what happens. Let me just go and bring my screen up a bit higher. And it gives us a 4. So what happens? We know that 9, ever since, what, 4th, 5th grade, 3rd grade, 6th grade, we know that 9 divided by 2 should be 4.5. So have your math teachers been lying to you guys all this time? No. So one of the things that we have to be careful is whenever we are working with integers, we have integers and we have double. So even though it's supposed to be 4.5, because integers have a smaller space, it gets chopped down. Because double will take twice as much space. It takes 64 bits. When integer will take 8 times 4 is 32. So therefore, whenever, and remember that we are working backwards. Whenever you divide 9 divided by 2, because 9 is an integer and 2 is an integer, therefore, Java, it's going to calculate this section first and say, well, 9 is an integer and 2 is an integer, so therefore when I divide it, I'm going to store it in an integer, which is only enough it doesn't have enough space to hold a decimal place. So therefore, it stores this as a 4. In order to be able to fix that, some of you might think, well, then can I just make this a double? Can I make this a double? Will that fix it? What do you think? So now we are going to store 9 divided by 2 directly into a double. So your answer should be, this time around should be a, well, we might think that's 4.5, correct? But no. Well, our answer is a decimal place, so our answer is a double. But the way Java works is that because it's going to calculate this part here before it calculates that. So it's not going to calculate that yet. It's going to do 9 divided by 2, which will be a integer. Then the integer will be placed as a inside the double. But then in here, we already got rid of the decimal place. So therefore, we no longer have the decimal place. So once it gets stored into the z value, the decimal place is lost. So yes, we did store into a double, but we lost the 0.5 beforehand. So one way to fix it is as follows. There's going to be 2 ways that we're going to fix it, but for now, what we're going to do 1.0 times. And sometimes we don't even place the parentheses. We just say 1.0. We are going to multiply by 1. And because this is a double, we know that by order of operations, PEMDAS, please excuse my dear Aunt Sally, we know that by the order of operations, this is going to be calculated first. This part right there. The 1.0 times x, which is a double. Then, because that's a double, once it gets divided by an integer, it is 4.5. And that gets stored into z, which is 4.5. So therefore, if I run it now, let me go ahead and run it. Now we have 4.5. So that is something that you want to make sure that you are careful. So whenever we divide, that decimal place is going to get chopped off. In order to be able to avoid this, we might think that we can do it the following way, but no, because of order of operations, this gets calculated first, 9 divided by 2, and because they both are integers, it's going to get the answer first, which is going to be an integer, and then it gets stored into a double. But that's not going to be good enough because we already lost the decimal place. So therefore, we want to make sure that if we do want to keep the decimal, and that is if we do want to keep the decimal, we want to be able to multiply by 1.0 beforehand. And that is going to be a very common mistake, that we have an integer divided by an integer. 9 divided by 2, you're going to think it's 4.5. But because the decimal got chopped off, because the Java calculated that first and thought that it was an integer, even though you place it as a double, it's going to be 4.0. In order to be able to avoid that problem, you have to do this operation first, 1.0 times, because that is going to calculate this part first, right? Multiplication before division, or just order of operations. Please excuse my dear Aunt Sally. Then, therefore, from here to here gets calculated first, which is a double. That means that's going to be a decimal. So now it's going to be 9.0. And because 9.0 is a double, once it gets divided by an integer, then it's going to be 4.5. We are not going to no longer lose the decimal place. We have what we wanted. Now, there are going to be times that you actually do want to get rid of it. So I did not type this into your notes, but if you guys can take some time to write this on your notes, there's going to be times that we just want to be able to chop the last number off. So therefore, if I do 7,623 divided by 10, we just lose the last number and we end up with 762. And we take that number and divide by 100, we lose the last two digits, right? Because it's not going to give us 76.23. We lose it, and therefore we end up with 76. Or if we take 7,623 divided by 1,000, ideally it should be 7.623. But because we are dividing two integers, two ints, we lose the decimal place and we end up with 7. And that is going to be useful in some of the algorithms that you guys will have to perform. So just keep that in mind. Notice that if we divide by 0, it's going to give us an error. So let's try that. Let's try that first. Let's say I divide, and let's just go and say we're going to divide 9 by 0. Now, if you compile it, so if we are working on any other ID that's not replet, when you compile it, it's going to be fine. But once you run it, it's going to give you a arithmetic exception. Now, you don't need to know this for the AP exam, the actual wording for it, but you do need to be able to know that whenever you divide a number by 0, it's going to give you an error. So keep that in mind. And we're actually going to be coming back to that once we go into if statements, but that'll be later on. For now, you have to remember, just like your math teachers told you, you cannot divide by 0. Java is telling you, you cannot divide by 0. Now, there are going to be times that we just need to be able to add 1 to a number, or we can add more than 1. So let's say we are going to take x, and now that we declare it, remember that's the declaration, and then that we declare it in this part, and then we initialize it at the same time. Remember that we were doing it in 2 steps before. This is what we were doing before, correct? We were doing declaring it first, then we were initializing it next. But now we actually learn a little more that we can actually do it in one step. We declare it in this part, and then we initialize it in that part. And that's what we learned in the last section. In this case, the y, we declare it, and then we initialize it. So you need to be able to remember the vocabulary. If you do it separately, so repeat after me. In this step, you are declaring the variable. In this step, you are initializing the variable. In this step, you are declaring, if I can spell it correctly, and initializing. So you want to be able to know the terminology. Declaring, initializing. In this case, we're doing two things at once. We are going to declare it, and we're going to initialize it in the same step. Keep that there, so you don't even forget. Now, let's say we wanted to be able to increase x by 2. So in this case, if we want to be able to increase it by 2, we can say x equals x itself plus 2. Remember that you are going to go backwards. So whenever you are working with Java, you are working backwards. So it's 2. We performing this part here, that part here, x plus 2, that 9 plus 2 is 11, and that gets placed back into x. So remember that we are x plus 2, and then that will be placed into the variable x. So therefore, what should be the value of, if I print x now, if I print x instead of z, what should be the value of x? The value of x should be 9. That is correct. Now, in Java, well, we can do minus in Java, and that will give us, if I do a minus, will be give me a, oh, I didn't click. If I do a minus, I'm going to get a 7, right? And then if I do afterwards, if I do x again, equals x plus 10, what should be the value of x now? The value of x should be, correct, it should be 17, because it was 7 before, and now we added 10 more. And then we can continue, and we can continue assigning the x different values, minus 20. So it was 2, minus 2, that was 7, plus 10 gives us 17, minus 20 will give us negative 3. Remember, integers can also be negative. Now, in Java, one of the things that we do quite often is that we actually want to increase the value by 1. And that is because a lot of times we are counting. We are counting how many times we do an event. So many times we are wanting to do x plus 1. And we want to do that over and over again. X equal x plus 1. And because in programming that happens quite a bit. And now let's say let's go and print the statement after we add each number. So let's do system .out.print, and then you want to be able to practice just typing this over and over again, so it kind of sticks in your head. And then so we add 1, then we're going to print it, and then we add another one, and that will give us, so it's 9, it's going to give you 10, and then it's going to give you 11. Let's see if that's correct. Let me bring this up so that way we can scroll through it. We can see it there. And in Java, we have to do this, so many times that we actually have a shortcut. We actually can have x plus plus. Those two statements are exactly the same. So whenever you want to be able to add 1, it's going to store it back into x. So therefore, notice that if I run, it gives us the same thing that we had before. So that is something that you want to get used to doing it, because we're going to be doing it over and over again in the class. And if I do this statement, that is x plus plus, that'll be exactly the same. Let's go and run it. And perfect. Now, you might want to say, so if we want to subtract 1, we can do minus minus, correct? So we have x plus plus and x minus minus. And that should give us, it was 9, then 8, and then 7. So those two statements are very, very useful. Now, if you want to do it the longer way, be my guest. Will it still get it correct? Yes, it's perfectly okay. But then after a while, you want to be able to get a little faster at this. Remember, in computer science, you want to be able to learn all the shortcuts. Not the shortcuts of the shortcuts like the keyboard shortcuts. You want to be able to learn the condensed way. Not cheating, but just the condensed way of doing things. And notice that gives us exactly the same answer. So therefore, that is what we call an increment and decrement operators, and that will have you here. So therefore, you can increase or decrease a number. Now, one of the things that I did include on your notes is that sometimes there's going to be times that we do place we do place the plus plus afterwards. I kind of give it to you guys so that way you guys have it as a reference, so that way in case you do see later on you won't say, hold on, Diaz never taught me this. We never covered this. That is, you can also place a plus plus beforehand, but in this class we're not going to be using this. So you might want to make a note to yourself. But I have it there just so you have it as a reference. So in case, that means that it's going to be able to increase it before and then do the operation. But for now, don't worry about this part. I just left it there so for you to be able to have it as a reference. Now we also have compounding assignment operators. So therefore, we can also add, if we want to be able to do +2, then and +2. Notice that we have a 11, then a 13. So the other way that we can have it as a shortcut is that we can have plus equal to 2. And that's going to be useful once in a while in this class, but if you want, you can just do a x plus 2. Both of them will give you the same performance. So instead of x plus 2, we can do plus equal to 2. That should give me also 11 and 13, and it does. Now we can also even divide. So let's say I say divide it by, let's not do 2, let's do 3, and divide it by, so therefore we have 9. Then we're going to divide by 3 will give us 3. And then we're going to divide by 3 again, it's going to give us 1. Is it? Let's try it. Excellent. And we also have, we can do also the multiplication. So we have those, and there are listed here. So we can do it times 7, we can do a minus, and we can division. The ones that we usually use the most is the plus equals and the minus equal, but we can also do the other ones as well. Notice that we also have a little, sometimes we do a little more compound, but I prefer if you just do it in 2 different steps, because otherwise it gets a little more challenging. So therefore, this will conclude the lesson for 1.4 number calculations. Thank you guys so much for your time. I appreciate all your time, and I'll see you guys next time. Email me if you have any questions. Have a great day.